This video is brought to you by JLCPCB. Over the last 3 years, I made several IoT-based projects using the legacy version of Blynk, Blynk Legacy or Blynk 1.0. And the bad news is the legacy server is going to be completely shut down on December 31, 2022. So if you have an older version of the Blynk installed in your cell phone, stop using it because number 1, Blynk Legacy platform support has already stopped on May 27, 2021. Number 2, Blynk Legacy app closed for new user registration on September 5, 2021. Number 3, it was already removed from the App Store and Google Play on June 30, 2022. But the Blynk 1.0 continue to work for existing users. So if you remove the older version of the Blynk, then you won't find it in the App Store and Google Play. Right now, if you go to the App Store and search for the Blynk app, you will see Blynk IoT. Number 4, in-app purchases deprecated on September 30, 2022. And number 5 is, I have already said earlier, the Blynk Legacy server is going to be completely shut down on December 31, 2022. This means we have to migrate from Blynk 1.0 to Blynk 2.0. Blynk 2.0 is much more powerful than the legacy version, and it maintains the familiar graphical user interface for creating mobile applications, and you can also add a cloud dashboard just like Adafruit, Arduino IoT Cloud, UV Dots, ThinkSpeak, etc. So before the Blynk 1.0 completely shut down by the end of this year, I decided to make a getting started video on the new Blynk V2.0. After watching this getting started video, then you will be able to migrate any project from Blynk 1.0 to Blynk 2.0. As a beginner, the only things you need to focus on are number 1, how to set up a dashboard on Blynk.cloud. Number 2, how to add different widgets in Blynk mobile app. And number 3, the most important one, how to use virtual pins to send and receive data from a Wi-Fi supported controller board like ESP32 or ESP8266, etc. And this is what I'm going to explain in this video. I will be making a two-way communication system for controlling an LED and for monitoring a potentiometer. After learning the very basics, then you can replace this LED with a relay or a MOSFET for controlling high ampere loads, and the same thing applies to the potentiometer, which you can replace with any analog or digital sensor. Anyway, first I'm going to share with you the final test results, and afterward I will explain everything else. This video is sponsored by JLCPCB. Feel free to visit their website jlcpcb.com/scale to not only find out what awesome PCB and assembly services they offer, but also to easily upload your Gerber files. It automatically detects the number of layers and dimensions. Select the number of PCBs you want to order. Select your favorite PCB color. The price is automatically updated as you select different features. Finally, you can click on the Save to Cart button. You will only need to pay $2 for 1 to 4 layers PCBs and $0 for your PCB assembly. Besides this, JLCPCB also offers industrial 3D printing services starting at only $1. You can start by clicking on the first link in the description. I have connected the potentiometer and LED as per the circuit diagram, which I will explain in a minute. Right now my ESP32 development board is connected with a Wi-Fi. Now using my cell phone, I can control this LED and monitor this potentiometer from any part of the world, provided if an internet connection is available. I can also do the same exact thing using my designed dashboard on the Blynk.cloud. I'm sure by now you might have got an idea of how does the system work. So without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. I'm using GPIO 0 to control the LED, and I'm using GPIO 36 for monitoring the potentiometer. If you want to use your laptop or PC for powering up your ESP32 Wi-Fi plus Bluetooth module, then there is no need to add this regular 5-volt power supply. You will only need this if you want to externally power up your entire project. These are the PCB boards which I received from the JLCPCB. As you can see, the quality is really great. The silk screen is quite clear and the Blynk solar mask looks amazing. Next, I started off by placing the components and completed the soldering job. This is how my ESP32 development board look after soldering all the components. I will use this development board for testing all my ESP32 based projects. For now, forget about all these relays. Anyway, I connected the LED and potentiometer as per the circuit diagram, and now let's start with the Blynk. Go to Blynk.cloud and register a free account. There is nothing complicated, just follow the same exact steps. If you want to follow a step-by-step guide, then you can click on the Let's Go button. It will help you with hardware setup, IDE, Blynk library, code and device activation. Anyway, I'm going to continue by clicking on the Cancel button. Free plan supports 5 users and 2 devices. If you want more users and devices, then simply click on the Get More button. Anyway, I'm going to start by clicking on the templates. Enter the template name. Select the hardware type. Select connection type. You can also write a description. Finally, click on the Done button. On the data streams, click on the new data stream and select virtual pin. Write the name. Select virtual pin data type. You can also select units and you can also set the minimum and maximum limits. After all the parameters are set, then you can click on the Create button. Now again click on the new data stream button and follow the same exact steps for the potentiometer. You can also see virtual pin is automatically incremented. After you have defined all the parameters, then you can click on the Create button. Our 2 data streams are ready and now we can click on the Save button. Now go to Web Dashboard. Click on the Edit button. drag and drop the switch for controlling the LED. Click on the settings. Select the data stream. Activate the show on-off labels. If you want, you can also change the color. Finally, click on the Save button. Now I'm going to add a gauge for monitoring the potentiometer. Once you have added all the widgets, then click on the Save button. My dashboard is ready. Now I can use this button to control the LED and gauge for monitoring the potentiometer. Click on the search. Click on New Device. Click on From Template to create a new device. Select the template we just created. Now we have to use the template ID, device name and authorization token in the programming. Copy the template ID and paste it next to the Blynk template ID. Repeat the same steps for the device name and authorization token. You can download this entire project code from our website electronicclinic.com. I will provide a link in the description. Finally, you can click on the Upload button. You will also need to install Wi-Fi.h, Wi-Fi client.h and Blynk Simple ESP32.h libraries. For this, you can watch my getting started video on the ESP32 Wi-Fi plus Bluetooth module. Using these steps, you can migrate all your Blynk 1.0 projects to Blynk 2.0. Anyway, once the code is uploaded, go to the App Store and search for the Blynk app. Make sure you install the Blynk IoT. Once the Blynk IoT app is installed, then log in with the same Gmail ID. Click on the developer mode. Add a button. Click on the button. Select data stream. Select switch. Now add a gauge and repeat the same steps. My Blynk mobile app is also ready, and now let's start the testing. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.